Now for some exciting stuff. So who knows why you might want server-side rendering?
Faster?
It's faster, right. So with typical client-side rendering, you end up serving up an empty index.html. Think of it almost like it has a body with nothing in it. And the reason is it's the client's job to determine where to go from there. And here's the downside, because this is the typical setup for client-side rendering. The user requests index.html, they get it back, right? And inside your HTML file, you have script references to external scripts and external CSS style sheets and images and things. So you start downloading static assets, usually from a CDN, if this is like a production grade setup. And those eventually come back. The CSS is relatively small. The JavaScript is usually huge. And particularly when you add on top of that the time it takes to parse that JavaScript, turn the text into code, and to run it to initialize your app, by the time the JavaScript is ready and your app is booting, a non-trivial amount of time has passed. And that's when you get your first render, right? So you have all of your templates and your other JavaScript code. That's all lumped together in these. That's the longest tail here, and you have to wait for that to land on your browser before you can really paint anything meaningful. And there are ways to make this better. Like you can have a spinner that'll be there in the index.html with inline CSS that just starts as soon as that lands. But you can't have a meaningful thing on the screen because you don't know what that would be, right? Your static hosting has no awareness of what URL the user even came into when they hit your app. So ultimately, at that point, you can start getting data, right? And then that's the point at which you can start showing the first data-oriented stuff on the screen. Pretty late in the game as far as this goes. So the trend now is to build things that operate quickly, things that are very performant, particularly on mobile devices, because we see that mobile traffic it has eclipsed desktop web traffic and is continuing momentum in that direction. So there's this concept of a progressive web app, and this has a lot to do with making it fast, making it so that it can be tolerant of a flaky or broken network connection, and it has to be interactive, very quickly after the user attempts to visit it. So some key metrics when you're considering progressive web apps are the time to first meaningful paint, and that just means a loading spinner does not count. Time to first interaction, which means you can click a button or you can navigate around the app, right? And the presence of metadata, and this is particularly important for mobile devices where you might want the user to add your app to their Android home screen in the form of a web clip. Or you might, in Android in particular, you can provide some metadata that will inform the browser to change the color of its address bar so you can match the theme of that site. You can provide splash screens where if the user launches your web app via their home screen, while you're waiting for everything to start up, you'll see an image just like a native app, while you're waiting for everything to kick up. So another part of this that we're not going to cover in detail today is this idea of service workers. I will explain what they are and why they're important, but we're not going to go into how they are used in an Ember app. This service workers are what give you resiliency to poor quality network connections. And then finally, SEO and having structured data in your HTML is increasingly important, not just for search engines, which a modern web crawler will actually run JavaScript, right? It'll actually launch a single page app and it'll crawl through everything and it'll find what it needs to find. But if you're thinking about the ability to share links on Twitter or Facebook or anything like that, you need to have Open Graph meta tags and Twitter card tags. And Google has this concept of schema.org structured data blocks, which is essentially JSON inside a special script tag. And this is what is used for optimizing a search experience where when you search for something, you see those nice little rich panels on the side of search results, and you can see, this is Frontend Masters, and here are all of the courses that Frontend Masters offers with little video thumbnails for each course. It helps a search engine when you can define structured metadata about what's on this page. And in theory, although it's tough to figure out what actually affects SEO and what doesn't, but there is some indication that because these richer results are more likely to get user engagement, that this is an easy way to get a boost to your SEO. And it only works with server-side rendering because all that is fetched for this kind of stuff is your index.html. So this is why fastboot. This is why server-side rendering is important. So there's a great tool that's sort of becoming the standard for measuring a web app's progressive web app like readiness, for measuring how ready you are with respect to these new metrics. And it is called Lighthouse. So it's a Chrome plugin that you can install, and it'll score your site from 0 to 100, and you can see we're timing the first meaningful paint. We make sure that we redirect plain HTTP traffic to HTTPS. At the bottom, you can see that we have this manifest file, which is has a lot of the mobile-specific metadata about icons and about colors that we want the Chrome of the browser to change to. And you can even see here that for this site that I was testing, a service worker is available. So even when we go offline, the most recent JavaScript and CSS are cached locally. Even when you open up a new browser tab, it is still there waiting for you. So to contrast, with the diagram I showed you for a static hosting setup, here is the way things are typically set up for fastboot. And indeed for server-side rendering with Angular 2 or React, it's basically, this is sort of a beyond Ember concept, but it is important to know this so that you understand how to reap the benefits of this feature. So the user requests index.html, and potentially right in your asset serving layer, on the critical path to rendering that index.html for that page the user's requested. It's not this generic blank index thing. It is essentially starting your app up in Node.js, rendering the templates necessary, resolving those routes, fetching that data from your API. It may go to the API and get a response back and serve back a fully populated page that'll look just like when you see your client-side Ember app having settled after rendering a route, rendering a template on a particular route. So at this point, you've got your HTML, and if you've used HTML semantics to your advantage, meaning your page still looks pretty reasonable without CSS, without external CSS, you could see something here that would allow a user to begin reading an article or something like that. So text is on the screen. And pretty quickly thereafter, CSS will come back and it will land. So now we don't have to wait for the client-side JavaScript to land. We're going to have an app there that looks fully styled, basically as soon as that first style sheet hits your browser. And particularly if they may have that CSS already cached, remember your style sheet is unlikely to change as you move from page to page to page within your single page app. They may already have that ready to go and cached. And so they're just waiting for index.html. So we've cut this down from a few seconds to render to usually like well less than a second. Particularly if you set your fastboot server up with some speed improvements to it. And then beyond that, we can get auxiliary data on the client side as we start navigating around and things pick up as we would expect. So the way to improve speed further is to basically add Redis on top of your fastboot server. So if the user requests the same index.html a couple times, you'll have that stored in there, potentially for that particular user. Or if they're logged out, that is a cached index.html string that everyone can share. And to also make use of a service worker, which again is, you can think of it like a local proxy and cache within that browser that takes almost no time for those static assets to come back. And you can set your service worker up such that you'll even serve the old CSS and the old application.js while you go and download the new stuff in the background. So you can really make it so that it is very, very snappy and very responsive. And keep in mind that like this, like steps 2 and 3 here, that is usually going to be within the same data center, right? So fetching data and coming back to the fast boot server, that is really, really, really fast. That is over usually like fiber optic connection if you've put all of your things close together as you should for something like this. And then getting your JavaScript back, that can happen almost instantaneously, and just because the files are already there, the data is in memory. So this is how you can get like well below 1 second in terms of that first meaningful paint. So any questions on that before I move on? This is a superfluous slide here that I meant to delete. Sorry about that.